All right, continuing on with our function work, we have spent a good bit of time for the last week or so talking about equations as functions and working with function notation. So, quick review here of function notation. And at this point, I hope you have a really good grasp of this. If you don't, if there's anything about this that is not making sense to you, then please let me know, because this is super important stuff. So what we've learned is we have this function notation, and we read this f of x, a function of x, is equal to y. So a function of x is equal to y, because we know that's what functions do. Functions take x's and connect them or relate them to y values. So the f, we know, is the name of the function. We know that x always represents an input, something we are going to plug into that function. And the y represents the output, the answer that we're going to get back from the function. So the function takes that x that you input, does something to it, and produces that output that is related. Now, we have also seen this get more specific. So instead of f of x is equal to y, we have also seen function rules, where we could have something like f of x is equal to 5x minus 2. So when we see this, we know that the f is still the name, the x is still the input, but now this 5x minus 2 is our function rule. And what that does is it tells me how the output is going to be produced. When I input an x, this function is going to do 5 times whatever x is and subtract 2, and that's how it'll give the output. That's how it'll figure out what that output needs to be. So these function rules are especially useful because they tell us specifically how x's and y's are related by a particular function. So we've worked with all of this for a few days now. Hopefully we're getting good and comfortable with that, and if not, you're going to let me know. But today what we want to do is talk about a special type of function called a piecewise function. And we are actually going to deal with piecewise functions for the next couple of lessons. We're going to be evaluating them today and then graphing them later in the week. Now, here's what we need to know about a piecewise function. A piecewise function is a function that has different rules for different parts or pieces, let's say it that way, for different pieces of its domain. So notice what's going to happen here with a piecewise function. It is going to have different rules for different pieces of the domain. Now, recall here what domain is. Domain is your set of inputs, and inputs are always x values. So what this definition is telling us is that for different x values, there will be different rules that we're going to use. So that's what all this boils down to. In a piecewise function, there will be different rules that you use, and those different rules will be determined by the x values, the inputs for that function. All right, so let me give you an example. Now, A piecewise function is going to start out the way all functions do, with f of x or g of x or that function notation. So this says a function of x equals. Now here's where things will be kind of a departure from what we've been used to seeing. You're going to see a brace. And the purpose of that brace is that this function is going to have different rules for different parts of the domain. So it's going to be broken into pieces. So here are the pieces of this function. Here's the first rule he's going to use. F of x is equal to negative 2 times x plus 1. Now that's pretty standard. We've been seeing things that look like that for a while now. But here's where it's going to be different. There's going to be an if statement that comes after that rule. So negative 2x plus 1 is one of f of x's rules. And you're going to use this rule if negative 3 is less than or equal to x, which is less than 1. So I mentioned to you that a piecewise function would have different rules for different parts of the domain, for different pieces of the domain. So what this is telling you is that when the domain is this, when negative 3 is less than or equal to x and x is less than 1, then this will be the function rule that you use. Here's part 2. F of x will equal 2x. So new function rule, if x is equal to 1. So when the domain is x is equal to 1, this is the rule. Now you might look at this and say, now wait a minute. This first domain had 1 in it, this second domain had 1 in it, but I want you to notice the difference. This says that x is less than 1. So in this domain, x can't be equal to 1. He has to be less than. If x is equal to 1, then this is your rule. And then one more. Let's make this a three-piece piecewise function. Our last rule for f of x will be x squared. And we'll use that rule if x is greater than 1. So this is what piecewise functions will look like. And piecewise functions are made up of 2 or more rules. So this specific function is broken into 3 pieces. The rule will be negative 2x plus 1 if x meets this criteria. It'll be 2x if x meets this criteria, and it'll be x squared if x meets this criteria. So notice that with each rule, you get a domain, a piece of the domain where that is the rule that you would use. So all of this over here, I wrote that up too high, and this stuff is getting in my way, but all of this over here is your domain. All right, so now, here's the kind of problem you're going to see with this, and we're going to do some parts here. First thing we're going to do on this problem is we are going to find f of negative 2. First thing we're going to find is f of negative 2. Now, here's something else that we need to recall about functions. We need to recall that for functions, for each specific input that we give the function, we should get exactly one output. So when I put in this specific input of negative 2, I should get back exactly one answer, exactly one output. Now why am I saying that? Well, I'm saying that because I want you to understand that in this problem you are not going to take that negative 2 as an input and plug it into all 3 parts of f of x. Because if I take negative 2 and I plug it into all 3 parts of f of x, then I'm going to get 3 answers. I'm going to have that one-to-many situation where that negative 2 is related to many different x values. And I can't have that in a function. So here is where your domains come into play. All right? When it says find f of negative 2 for this piecewise function, you are only going to input negative 2 into one of these 3 rules. Now I want you to listen again to what I said there. You are only going to input negative 2 for x in one of those rules. Now how are you going to know which rule? Well, you are going to know which rule by taking negative 2 and seeing where it fits in these domains. Is negative 2 in this domain? is negative 3 less than or equal to negative 2? Yes. Is negative 2 also less than 1? Yes. So negative 2 fits this first domain. Negative 3 is less than or equal to negative 2, and negative 2 is less than 1. So negative 2 fits here. Okay? Check out this domain. If x is negative 2, is negative 2 equal to 1? No. Check out this last domain. X is greater than 1. Is negative 2 greater than 1? No. So what I want you to notice is that input value of negative 2 only fits one of these three domains, and it's the first one. Negative 3 is less than or equal to negative 2, and negative 2 is less than 1. Negative 2 is not equal to 1, negative 2 is not greater than 1. So what that tells me is if I need to find f of negative 2 in this piecewise function, rule 1 is the piece that fits it. Rule 1 has the domain that I need to do that. Okay? So we're going to take negative 2 and input it for x in the first piece of this function. So we're going to do a negative 2 times a negative 2 plus 1. You use the first piece because negative 2 fits his domain. All right, so negative 2 times negative 2 would be a positive 4, and positive 4 plus 1 would be 5. So in this piecewise function, an input of negative 2 is related or connected to an output of 5. I have a one input produces exactly one output relationship there, which fits with my idea of a function. All right, let's try another one. Let's find, using this same function, f of 1. So notice my input, my x value, the member of the domain that I want to use is 1. So what I have to do to figure out which piece, which rule to use, is I need to look at that number 1 and see which domain he fits. Is negative 3 less than or equal to 1? Yes. Is 1 also less than 1? No. So 1 does not fit this domain. 1 would work with the negative 3 part. Negative 3 is less than or equal to 1, but 1 is less than 1 is not true. So I don't want to use the first piece of the function to figure this out because 1 doesn't fit his domain. All right, the second domain says x is equal to 1. What about my number? Is 1 equal to 1? Yes. So piece number 2 is what I would use to find f of 1 because the 1 fits his domain. And just to kind of emphasize why we're not going to do the x squared part of this, f of x is x squared if x is greater than 1. Is my number 1 greater than 1? No, he's not. So notice again how this number 1 only fits one of these three domains, and it's the second one. So to do this problem, I would use the second piece of the function. So I would input 1 for the x in 2x and have 2 times 1, which would be 2. So this piecewise function takes an input of 1 and connects it to an output of 2. But I want you to notice how you're only using one piece. One piece. And you determine which piece by looking at your number, your input number, and seeing which domain he fits. All right, f of 4. Let's find f of 4 using this piecewise function. Again, I got to figure out which piece of the function to use, which rule. So take your 4 and fit him into this domain and see if it works. Is negative 3 less than or equal to 4? Well, sure he is. Is 4 also less than 1? No. So f of 4 cannot be found using the first rule because 4 doesn't fit his domain. All right, take your 4 for x and let's test him in this second domain. Is 4 equal to 1? No. So I can't use the second rule to do this problem because 4 doesn't fit his domain. Take the 4, test him in this last domain. Is 4 greater than 1? Absolutely. Absolutely. So I found my rule. To evaluate f of 4, I need to use rule number 3 because the 4 fits in with his domain. So I'm going to input 4 for x, which will make this 4 squared. And 4 squared we know is 16. So this function would take an x of 4 and connect it to a y of 16. Input right here, output right here. So this is the most important thing for you to understand about these piecewise functions for today, is that no matter how many pieces that function is broken into, no matter how many different rules he has, you are only going to use one piece, one rule. And you will determine which piece to use or which rule to use by looking at the x value that you have been given and seeing which domain he fits. Does he fit domain number 1, domain number 2, or domain number 3? Which one does he fit? Because if you can determine which one of these domains that he fits, then you'll know which rule you're supposed to be using. All right, let's look at one more. F of x equals two x minus 4 will be the rule if -1 is less than or equal to x and x is less than or equal to 2. So for this domain, use this rule, 2x minus 4. F of x will be x squared minus 2x plus 3 if the domain is 2 is less than x, which is less than or equal to 3. So I want you to notice that in the two domains you do have 2 in both of them. 2 is included up here because it says that x can be less than or equal to 2. So x can actually be equal to 2 up here. Down here it says that 2 is less than x. So notice that the 2 cannot be the x value in that particular function. So this is the domain that will cause you to use the first piece. This is the domain that will cause you to use the second piece. All right, so let's try some problems. First one we're going to do is f of 0. F of 0. So 0 is my x. 0 is my domain number. So I need to figure out whether that 0 fits into rule 1 or into rule 2. So think about putting a 0 right where that x is. Is -1 less than or equal to 0? Absolutely. Is 0 also less than or equal to 2? Absolutely. So 0 fits this domain, which means he shouldn't fit this one. Is 2 less than 0? No. No. So 0 does not fit this domain. So for this particular problem, I would use piece 1 of my function because 0 fits in his domain. So we're going to input 0 for x in that first rule. So that would be 2 times 0 minus 4. 2 times 0 we know is 0. 0 minus 4 is a -4. So notice, once you determine which rule to use, this is really, really simple stuff. This is just plugging in. All right, let's do f of 1. F of 1. So again here, I'm going to plug 1 in to one of these two rules, never both. So to figure out which rule to plug into, I have to take that 1 and figure out which domain he belongs to. And I think we can all see 1 fits in with this first domain. -1 is less than or equal to 1 as an x value, and 1 is less than or equal to 2. 1 would not fit right here for x. 2 is not less than 1. So 1 fits in with that first domain. So we're going to use the first piece of the function and input 1 for his x. So we're going to do 2 times 1 minus 4. 2 times 1 is 2. And 2 minus 4 is -2. So notice, I'm not getting 1 to many. I'm getting 1 input going in and 1 output coming out. All right, let's do f of 2. Let's do f of 2. Now again here, I'm going to take 2 and input it for x, either in the first piece of the function or the second piece. And to figure out which piece to use, I got to see where 2 fits into these two domains. So take a minute and look. Which domain do you think that 2 fits in with? should be the first one, because -1 is less than or equal to 2 would work, and 2 is less than or equal to 2 would work because of the equal to. Wouldn't fit here because 2 is not less than 2. We need that equal to bar. So again, this is first rule. So we're going to take 2x minus 4 and input a 2 for his x. 2 times 2 is 4. 4 minus 4 is 0. The output would be 0. One last one. Let's do f of 3. Now again, I'm going to input a 3 for x into either the first piece of the function or the second piece of the function. To figure out which piece to use, I take this 3 and I see which domain he fits. It's definitely not the first one. I can't put a 3 right here. -1 is less than or equal to 3 would be okay, but 3 less than or equal to 2 would not. So 3 doesn't fit in this domain. He does fit here though. I can put a 3 right here. 2 is less than 3 would work. 3 is less than or equal to 3 would also work. So this is a job for the second piece of the function. I'm going to input 3 for both of these x's that I see right here. So this is going to be 3 to the second power minus 2 times 3 plus 3. Now we know we would do that exponent first, so 3 to the second power is 9 minus 2 times 3 plus 3. We would multiply next, so that would be 9 minus 6 plus 3. And then we would add and subtract left to right, so 9 minus 6 is 3. 3 plus 3 would be 6, so the output would be 6. So, piecewise functions are nothing more than functions that have been split into pieces. They have different rules that are the rule for different parts of the domain. So that's how the split is made. Different rules for different parts of the domain, different x values. So when they ask you to evaluate one of these functions, you are never plugging into all of the pieces, because remember, you don't want one input to produce many outputs. You want one specific input to have exactly one output. So to determine which rule to use, take your x value and see which domain it fits. Which domain is it in? And that will tell you which piece of the function to use to evaluate. If there are any questions at all, I know this is brand new to you. It's not something you would have ever done before. Please be sure and let me know.